Okay, we're going to look at probabilities, and we will start with some definitions, and we'll take an example for that. If we have a fair dice that is thrown, this is a dice with 6 sides, what is the probability that the number thrown is a multiple of 3? Well, we should solve this way. First of all, let's see how we write probability. We can say that the probability that an event occur is P of A, and we can write this as N of A, which is the number of ways in which this event A can occur, and divided by N of U, which is the total number of possible outcomes that we can have. So in our case, we are interested in P, the probability that we get a multiple of 3, and that is, well, let's say we have a dice and we have 1, 2, 3, 4, 5, 6. So the number 3 is a multiple of 3, and so is 6. So we have two possible outcomes for that, 2 possible ways that this event can occur. So 2 divided by the total number of possible outcomes, which is of course 6. So this we can also write as 1/3. So that's the probability that we get a multiple of 3 when we throw the dice once. We can also have another example here. If we take this, if the dice is thrown 60 times, how many times would you expect a multiple of 3? And here we can use, well, if we throw the dice 60 times, so N, the number of trials, equals 60, and the probability that we get a multiple of 3 when we throw the dice once, so the probability is 1/3. And if we throw this dice 60 times, then we would expect to get a multiple of 3 60 times 1/3, which is 60 divided by 3, which is 20 times. So we take N times P, there, where N is the number of trials, the number of times we throw the dice in this case, and P is the probability. And this we can call theoretical probability, because this is something we can find without making an experiment. I mean, we know we can just think which are the outcomes and how many possible outcomes do we have. However, often we need to do some kind of experiment if we want to investigate something. And here we have a student, Violet, who investigates the shoe color of students passing by the schoolyard. And the result is shown here. So we have the shoe color here and the frequency, that how many students had each color. And in total she investigated 134 students. And now, well, we can't find an exact probability, because if we would do the experiment again the next day, we would have another result. However, we can speak about the relative frequency that a student passing by the school has red shoes, for example, if you want to know this. What is the probability that the next student passing by the schoolyard has red shoes? And then we look here, okay, we got, in this experiment we had 14 students, so we can write the relative frequency, that is, we have 14 students with red shoes, and in total we had 134 students. And we can simplify this if we divide by 2, we in the numerator and the denominator we get 7 out of 67. So we could also like this, that the relative frequency for a student passing by the schoolyard to have red shoes is 7 out of divided by 67. Or we could also calculate this and get like a decimal, and this would equal then 10.4%. That's also a way of doing it. And so, well, as I said, if we repeat this experiment the next day, we would probably get another relative frequency for red shoes, for example. But if the number of trials is very big, the larger the number of trials is, the closer the relative frequency gets to the probability, which is logical. Because if you just investigate a few students, then you don't get a very reliable result. And this we can call then experimental probability, because we made like an experiment. We could not think it out like we did in the case with the dice. We also have something called subjective probability, and it's like if you think about a football game, for example, what is the probability that Malmö FF will win the next game in the Swedish league? And then you have to think about many parameters like the weather condition, the arbiter, the shape of the players, etc. So then you have to make some kind of guess, and that's why we call it subjective probability.